Okay, so this is part 2 of your pre-lesson for section 1-4, day 1. Ladies and gentlemen, lock and load. This is a big lesson, and this is going to do nothing but prepare you for the next stuff coming, okay? So I know there's part 1, those are your basics. Part 2, now we're going to start getting into the pre-calc/trig. And then, believe it or not, there's a part 3 pre-lesson in this section. It's just required. It'll make sense. So, here we go. What we're going to concentrate on today is this. Our goal is to understand this. And when I say this, I mean part A, part B, part C, part D, and what's the sine thing all about? So I don't blow you away on day 1 of this. Let's focus on y equals sine of x. Now, if you type that in your calculator, graphing calculator, and you know how to do that, what it's going to give you, it's going to give you something like this. Okay, so you might be saying, well, okay, if you already know that, then why are you giving us this pre-lesson? Because you need to know the language that goes along with it and also how to create it. Where does it come from? So this is opening up the hood and understanding how the motor works. Believe me, we're not going to do it in this great of detail once we get a million examples coming at us, I promise. But today I felt it was necessary. So we're going to start with this guy right here, y equals sine of x. First of all, what's y? This is your y-axis. That's your up and down value. So that's your typical y value. What's this x? Now this is where it gets right off the bat. This is new. Your x-axis is typically this. But now your x isn't really x, it's theta. So in these trigonometric functions, whatever you put in for your x, it's actually theta, but it's your x-axis. So you can see on my x-axis, I've got pi over 2, that's radians or degrees. Pi, that's 180 degrees or just pi radians, etc., etc. So this axis is your degree measure axis. Okay, so what am I going to plug in here to get started? To get started with this, I'm going to say, hey, let theta equal 0 degrees or 0 radians. So level number 1, you just take your handy dandy calculator, turn it on, obviously. I'm going to clear it all out. And I'm going to say, all right, I want to take sine of 0 degrees, and I'm going to hit enter. And my calculator says 0. What that means is I have my first coordinate point, and that is, remember, I said, hey, this is 0 degrees, so that means I start here, I don't move to the right, and I don't move to the left, I start there. And this is saying, hey, I plugged in 0 degrees, I hit enter, and it told me that my answer to it is 0. So that's y equals 0 and x equals 0. So that means, guess what? It's that point right there. Now let's go ahead and continue building this and keep plugging stuff in. So this is my theta, this is my f of x, or might as well just put y in there so it's more obvious. And let's move out a little bit. Now remember, this is pi over 2. I know it's a little smudgy, but it's pi over 2. What's pi over 2? 90. So in between here, I've got 30, I've got 45, and 60. We're going to investigate that. But before we do, remember we just found sine of 0 degrees equals 0? I want you guys to know more than how to use a calculator to figure that out. By the way, this stuff's going to be on your quizzes and tests. So look at this. This is a picture of what we just did. It means spin your 0 degrees. This is what we call a quadrantal. But this is my opposite side, which equals 0. This is my hypotenuse. Sine of 0 is just saying, okay, spin your 0 degrees, look at the triangle and figure out sine. Well, that's opposite over hypotenuse. Opposite side disappears. My hypotenuse is some number, but it's going to be 0 over some number, which is going to give us 0. So this is saying let x be 0, that's 0 degrees, and your y ends up being 0. So that's a different way of getting the coordinate point 0, 0 on this graph. Okay, let's keep going. I'm going to get rid of this so it doesn't confuse us when we get back over here. I'm going to move one little smidge out to 30 degrees. So now I'm going to take this and I'm going to put a 30 degrees in there. So how do we survive? Survival mode, we go to our calculator, we type in sine of 30 degrees, hit enter, My calculator spits out 0.5. You can see it. See that? 0.5. Question is, how come? Well, here's my 30-degree picture. So we spin our spinner 30 degrees. We label our sides. What is sine of 30 degrees? Well, it's opposite over hypotenuse, which is 1 over 2. So this is saying if x is 30 degrees, then y would equal 1/2. And there's my point. It's like this. Go out 30 degrees and then go up 1/2. So this is kind of like your x and your y. So I go here, I go to the right 30 degrees, which is not very far, and then I go up 1/2. All right, now we're going to venture on to the next thing, which is 45. So I'm going to change this to 45 degrees. So what I just said was, hey, let x equal 45 degrees. That means go out halfway to 90. The question is, how high is this going to take me? Well, I need to go over to this. Oh, I don't have it on the board. Good thing I erased something. So let me draw this. So there's my 45 degrees. This is my reference angle. This is a 1, that's the square root of 2. So the question is, what is sine of 45 degrees? Well, it's opposite over my hypotenuse. Now I know the square root of 2 is approximately 1.4. So I need to take my handy dandy calculator, and I'm going to just figure that out. 1 divided by 1.4, enter, and that's 0.71, but we're going to go with 0.7. And remember, by plugging that in, we're saying, hey, let x be 45 degrees, and your y ends up being 0.7. So that means I go out halfway to 90, and I go up 0.7. Okay, so that's 45. Two more. Let's calculate 60. Things should move along a little bit quicker here. 60 is my x. The question is, here's my drawing, 60 degrees, opposite over hypotenuse. All right, well, what is that? Well, that's 1.7 over 2. And let's get real accurate here. So 1.7 divided by 2. That gives me 0.85. So that means I need to go out 60 degrees, and then I need to go 0.85. You notice how this thing's going up and up and up and up and up? The last one I'm going to investigate is 90 degrees right here. This is what's called a quadrantal. I haven't done this yet or a while. Well, let's go ahead and just go sine of 90, enter. Okay, sine of 90, enter. Shows me a 1. Why is it a 1? Let me take a look at the time. Oh, we're doing good. Okay, so here's my opposite side and here's my hypotenuse. Isn't sine opposite over hypotenuse? And if they're both, if these two things are the same at 90 degrees, which they are, you're going to get 1. So here's my x, here's my y. So that means I go all the way over to pi over 2, which is 90, and it takes me up to 1. Now, we could sit here for the rest of our lives plugging points in, but what I'm going to show you is this ends up going like this. And it goes down to here, and then here, and then it goes here, and then it comes back down to there. It's not a perfect drawing, but it's good, okay? Now I'm going to break some things down that you need to know. First of all, this is considered the graph's amplitude, and it's 1, okay? It's 1. Now you could also find it right here. Now the amplitude's formula is the absolute value of A. Where does A come from? Right here. Well, look at it. Isn't there an invisible 1 right here? And that would be my A. So in a formula world, it would tell me, hey, take the absolute value of that, and it's going to be 1. See, some people might think of this as a negative 1, but don't think of it that way. It's just 1 down. So the amplitude is 1. That's the height of the curve above the x-axis, or how low it goes below the x-axis. There's your amplitude. Okay. There's another thing I want you to understand is, it's the word period. Period is the amount of time in degrees or radians it takes this graph to complete one cycle. So Let me check the time. All right. So I look at this drawing and I say, all right, I'm going to start here and go to the right. Notice it starts here, and that's at 0 degrees, and it goes up, and it goes down, and it comes up, and it would just it would repeat that same thing. So this right here would be considered one period. A period would be 2 pi in this case. So there it is. It takes that long to go through one cycle. Now, I'm not going to mess this drawing up anymore, but what if a student would have started here? Well, that's at negative pi. And then their drawing, I'm going to go ahead and get a different color. I'm going to make it red. They would have thought, okay, from here to here to here, it completes a cycle, and then it repeats the cycle from here to here. So a student might say, well, I want to pick from here to here. That's fine. What is it from negative pi all the way to positive pi? It's still 2 pi. It takes 2 pi to complete one cycle. That's the word period, okay? And there's more where that comes from, but I want to get this idea of amplitude and period going today. Yeah, I think that's good for this section. Okay, I think we're good.